try to understand buoyancy using an animation in a moment. We're going to try to float aluminium, an aluminium block in nitric acid. The density of aluminium is 2,750, and the density of nitric acid is 1,560. We're going to say that the volume of the block is 1 meter cubed. So will the block float? Quick answer is no, it won't float because the density of aluminium is greater than the density of nitric acid. What we want to do is try to understand whether or not it will float in terms of forces. So to do that, question 2, it says, what will the resultant force be when the block is entirely submerged? So we look at the block here, and we've got an up thrust acting up and weight acting down. And the resultant force will be equal to the difference between the two. And if we were working out the resultant upward force, we would do up thrust minus weight, or if it was a resulting downward force, the downward force would be weight minus up thrust. So the first thing we need to understand about up thrust is it's nothing more than the weight of the liquid that has been displaced. Up thrust is caused by the liquid trying to fall and therefore pushing the object up. So you can always calculate the up thrust of an object by multiplying the mass of the liquid that has been displaced by the strength of gravity. So in our case, we have the density of the objects. We don't have the masses, so we use this formula to relate the two because we do have the volume. So we're going to work out and then we can use that to calculate the forces afterwards. So if we go down here, we'll work out the mass of the liquid is going to be equal to the density of the liquid multiplied by the volume, which is 1,560 multiplied by 1. So the mass of the liquid is 1,560. So we've got the mass of the liquid, and we would multiply that by gravity, which we're going to say is 9.8, because the simulation also says it's 9.8. And we get this as a volume. This is the upthrust, or you can call, I think the simulation calls it buoyancy. But it's the same anyway. And then we've got the weight. We do the same sort of thing. We do the mass of the block multiplied by gravity, which is going to be the density of the block multiplied by the volume of the block multiplied by gravity, which is the density of the block was 2,750. That was density of aluminium. Go back up here, yeah. Multiplied by 1, which is the volume, multiplied by gravity, which is 9.8. We get 26,950. So we have this difference in. Now we can clearly see that in terms of forces, it's going to sink, which is what we said at the beginning, because the weight is greater than the upthrust. To work out what the resultant force is, to work out the resultant downward force, we would do the weight minus the upthrust, and we get this. So let's just look at these numbers, and we can run the experiment. This number here was the weight of the block. This number here was the upthrust, and this number here is the resultant force. Okay, so let's do the simulation. Well, yeah, I'd already done it, but first of all, we can see let's look at the net force, 26,950. That's what we calculated the weight of the object to be, 26,950. And in fact, it still says it here, 26,950. The buoyancy, so the upward lift, that the upthrust, 15,288. 15,288. The net force, 11,662. 11,662. So, and you can see it sinks. So we got that right. Now you can obviously use this simulation to test other things out. Will a brick float on mercury? Will ice float on crude oil, or whatever else? Okay. So, and then you can just look at the densities and then calculate it and see if you're right.